In this video, I will explain concept related to weighted resistor digital to analog converter. Weighted resistor digital to analog converter. Digital to analog converter. DAC. Here block diagram here is this one is minus. Two power 1 or 2 square or 2 cube or 2 power n into r. The current flow through this 2R is I1. 2 square R is the current flow through this 2 square R is I2. This 2 cube R is the current flow through this 2 cube R is I3. The current flow through this 2 power n into R is IN. This one is a switch. This one is switch. Switch is connected to either two positions. The switch is connected. This one is reference voltage, positive reference voltage here. The switch movement here, the resistor value is connected to either VR value or ground. This one is ground. This one is a switch. The switch is movement either in this direction or in this direction. The switch is movement is either in this direction or in this direction. In this direction. That means the resistance value is connected either VR or 0, depends on the binary values. If the binary value is 0, that means the resistance is connected to 0, here ground. If the binary value is 1, that means the resistance is connected to VR, like that. These are the data D1 here, D2, D3 and so on and so forth, Dn. This one is D1 is the MSB, Dn is the LSB. The circuit diagram, this weighted resistor diagram is connected to op-amp. This one is V0. RF, IF. Non-inverting terminal of the op amp is connected to ground. Here, according to virtual ground concept, VAD is equal to 0. VAD is equal to 0. The current flow through this also 0 here. The total current here is high. If the binary input to a particular switch is 1, it connects the resistance to the reference voltage VR. Suppose D1 is equal to 1. D1 is equal to 1. This is the binary switch. This is the binary switch. If the binary input to a particular switch is 1, that suppose D1 is equal to 1, it connects the resistance to the reference voltage, VR. D1 is equal to 1. Suppose, and if the input bit is 0, if the input bit is 0 means D1 is 0. Suppose if D1 is 1, if D1 is 0, the switch connects the switch connects the resistor to the ground. This one is the resistance 2 power on R. This one is input bit is represented by D1. If D1 is equal to 1, this is the switch. This one is VR. This one is VR. The switch is connected to VR only. The switch is connected to VR. If D1 is equal to 1. If the switch D1 is not connected to ground, because D1 is equal to 1. Suppose if D1 is equal to 0, if D1 is equal to 0, this one is VR. The switch is the switch D1, the switch here connected to ground only, not VR. In the similar fashion, based on that D1, D2, D3 and so on, so forth, Dn values, connections are made. This is the weighted, this is the diagram related to weighted resistors. Weighted resistors means 2 power 1 into R, 2 square into R, 2 cube into R, 2 power n R, 2 power n into R. This one is the least significant bit. This one is the most significant bit. Another way of representation of this diagram is weighted resistor digital to analog converter res diagram is, this one is minus plus. Two power 1 into R, next one 2 square R, 2 cube R. These are the switches like that. Last one is 2 power n into R, 2 power n into R. The switch is connected to either This one is VR. This one is VR. The switch movements are in either connected to either VR or ground. Depends on the values of the data. Here this one is D1, D2, D3 and DN. D1, D2, D3 and DN. Here this one is a most significant bit MSB, this one is a least significant bit LSB. The current flow through this one are I1, I2 and I3, IN. This one is output voltage V0, RF. The total current is IF current flow through this one like that. Here based on that the current direction is like that. The current direction is like that. Current direction is like that. Like that. Okay. This one is a switch. The current direction is like the total current I is equal to I1 plus I2 plus I3 and so on and so forth IN. This is the representation of a simple weighted resistor digital to analog converter. Next important point here is the op amp is connected. The op amp is connected in inverting mode. The op amp is converted in inverting mode because non-inverting terminal of that op amp is connected to ground. First important point here is this is the current I1, this one is current I2, this one is current I3, this current is IN, this is the IN. First point, the op amp is connected. The op amp is connected. The op amp is connected in inverting mode. It is also connected in non-inverting mode. It is also connected in. It is also connected in non-inverting mode. In non-inverting mode, this weighted resistor circuit diagram is connected to positive terminal of the op amp. Negative terminal of the op amp is connected to ground. The op amp is simply working as current to voltage converter. Here some currents are there. Representation I is equal to I1 plus I2 plus I3 plus I1. Here IF is equal to here non-inverting terminal of op amp is connected to ground. Here also 0 volts. Here 0 volts. Therefore I is equal to 0 minus V0 by RF. Therefore total representation is voltage current to voltage converter. The op amp is simply working as a current to voltage converter. Current to voltage converter. Current to voltage converter. Next, one more important point here is a weighted resistor DAC produces an analog output, that is V0, which is almost equal to the digital, that means binary input, by using a binary weighted resistor in the inverting adder circuit. One more important point here is a weighted resistor digital to analog converter produces an analog output voltage, an analog output, that is V0, which is almost equal to the digital binary input by using binary weighted resistors, in the inverting adder circuit. The op amp is simply working as a current to voltage converter. The binary weighted resistor DAC uses an op amp to sum n binary weighted currents, that means I1, I2 and so on and so forth, derived from a reference voltage VR via current scaling resistors 2R, 4R, 8R and so on and so forth to NR. The binary weighted resistor digital to analog converter uses an op amp to sum n binary weighted currents, that means I1, I2 and so on and so forth, IN, derived from a reference voltage, VR via current scaling resistors 2 power 1 into R 2 square R and so on and so forth, 2 power n into R. That means I1 is the current flow through this 2 power 1 into R whenever the switch is connected to VR. I2 is the current flow through this 2 square into R. The switch is connected to VR. The another end of the resistor is connected to VR, like that. These are the currents which are derived from a reference voltage VR via current scaling resistances. Current scaling resistances are 2R, 4R, 8R and so on and so forth, 2 power n R. Switch positions are controlled by the digital inputs. This is the switch. Movements in either towards VR or towards the ground depends on the digital inputs D1, D2 D3. If D1 is 1, 2 R resistor another end is connected to VR. If D1 is 0, 2 R resistor another end connected to ground, like that. Therefore, switch positions are controlled by digital inputs. One more important point here is switch positions. Switch positions are controlled. Switch positions are controlled by the digital inputs. Digital inputs D1, D2, and so on and so forth. Dn. When the digital input, when the digital input is at logic 1, is at logic 1, that means 1, it connects, that means VR, it connects the corresponding resistance, it connects the corresponding resistance connect to the reference, to the reference voltage VR. Otherwise, it connects to ground. Operational amplifier is used as summing amplifier. Operational amplifier is used as a summing amplifier. Here I is equal to I1 plus I2 plus I3 plus IN. Okay. Here operational amplifier is used as a summing amplifier. Is used as a summing amplifier. Summing amplifier. Therefore, total current I is equal to I1 plus I2 plus I3 and so on and so forth IN, and so on and so forth IN. Okay. But VID is equal to 0, open circuit condition. The total current I is flow through this RF only. Therefore, I is equal to IF. Therefore, I is equal to IF. I is equal to non-inverting terminal of op-amp is connected to ground. Therefore, here 0 volts. Here also 0 volts. Therefore, I is equal to IF is equal to 0 minus V0 by RF. I is equal to IF is equal to 0 minus V0 by RF. Therefore, V0 is equal to minus I into RF. We know that I is equal to I1 plus I2 plus I3 and so on and so forth IN into RF. How to determine I1, I2, I3 and so on and so forth IN? Here I1 is equal to, here data is D1 here. I1 is equal to VR by 2 power n into R. I2 is equal to VR by, when I1 is obtained, that particular corresponding resistance is connected to VR only. That corresponding resistance is connected to VR. Otherwise, I1 is equal to 0. The corresponding resistance is connected to here, that is 0. Therefore, I1 is equal to 0. Okay, depends on D1 value. Depends on D1 value. D1 is equal to 1. That corresponding resistance, that is a 2R, is connected to VR. Therefore, I1 is equal to VR by 2R. I1 is equal to VR by 2R into D1. Therefore, I1 is equal to D1 into VR by 2 power 1 R, I2 D2 into VR by 2 square R, D3 into VR by 2 cube R, and so on and so forth. Dn VR by 2 power n R into RF. Therefore, V0 is equal to RF is there, 1 by R term is there, minus RF by R. VR is a common term, VR, that is equal to D1 by 2 plus D2 by 2 square, D3 by 2 cube, and so on and so forth, Dn by 2 power n. Therefore, minus RF by R, VR, D1, 2 power minus 1, D2, 2 power minus 2, D3, 2 power minus 3, and so on and so forth, Dn, 2 power minus n. Therefore, analog output voltage V0 is proportional to digital word D1, D2, D3, and so on and so forth. Analog output voltage is proportional to the input digital word. Input digital word D1, D2, and so on and so forth, Dn. One more important here, D1 is MSB, Dn is LSB. Drawbacks. Wide range of resistor values are required for 8-bit digital analog converter. The weighted resistor values are generally drawbacks. The weighted resistors values are 2 power 1 R, 2 square R, 2 cube R, and so on and so forth, 2 power n R. Whenever n is equal to 8, n is equal to 8 means a wide range of resistor values are required for 8-bit digital to weighted digital to analog converter. The resistor required are 2R, 2 square R, 2 cube R, and 2 power 8 R. Therefore, the largest resistor is 128 times the smallest one. Wide range of resistor values are required. Resistor values are required for 8-bit digital to analog converter. The resistors required are 2R, 2 square R, 2 cube R, and so on and so forth, 2 power 8 R. Therefore, the largest resistor is therefore the largest resistor is 128 times the smallest one. The wide range of resistor values has restrictions on both higher and lower ends. It is impracticable to fabricate large value of resistor in IC, and voltage drop across such a large resistor due to bias current also affects the accuracy. Another drawback. Another drawback is the wide range of resistor values has restrictions on both higher and lower ends. It is impracticable to fabricate. It is impracticable. It is impracticable to fabricate large value of resistors on IC integrated circuit, and voltage drop across such a large resistor due to bias current also affects the accuracy. Also affects the accuracy. This is the analysis of weighted resistor binary to not binary, digital to analog converter. Suppose 3 bits are taken, 3 bits like that, serial number 1, digital inputs D1, D2, D3. This one is MSB, this one is LSB. 3 bit means 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and 311. The formula is used to calculate these values, analog output voltage values, by using weighted DAC. So the digital inputs. For positive reference voltage, we know that positive reference voltage V0. Suppose RF is equal to R. Therefore, suppose RF is equal to R, that is V0 is equal to VR into D1 into 2 power minus 1, D2 into 2 power minus 2, plus D3 into 2 power minus 3. Only 3 bits, that is minus VR. RF is equal to R, therefore V0 is equal to minus VR into D1 into 2 power minus 1 plus D2 into 2 power minus 2 plus D3 into 2 power minus 3. Only 3 bits are taken, digital bits, D1, D2, D3, D1, D2, D3. Okay. All are zeros, output is 0. Suppose D3 is 1, V0 is minus VR by 2 cube is 8. Here D2 is 1, 1 by 2 square, that is V0 is equal to minus zero 1 0, that is D2 is 1, minus VR by 4, minus VR by 8, minus VR by 4, that is equal to minus 2 into VR by 8, minus 2 into VR by 8. Here D2 D3 is equal to 1, that is V0 is equal to minus VR into 1 by 4 plus 1 by 8, that is equal to minus 3 VR by 8, minus 4 VR by 8, minus 5 VR by 8, minus 6 VR by 8. Okay. By using this one, draw the graph. This one is a digital input, digital input code, digital input code, analog output. Y-axis, negative y-axis is analog output. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 3 1. Minus 1 by 8 R, minus 2 by 8 R, minus 3 by 8 R, minus 4 by 8 R, minus 5 by 8 R, minus 6 by 8 into R. 0 0 means 0. here 0 0 0 0 0 1 minus 1 by 8 r 0 1 0 minus 2 by 8 r 0 1 1 minus 3 by 8 r 1 0 0 minus 4 by 8 r 1 0 1 minus 5 by 8 r 1 1 0 0 0 1 minus 1 by 8 r 0 1 0 minus 2 by 8 r 0 1 1 minus 3 by 8 r 1 0 0 minus 4 by 8 r 1 0 1 0 1 0 0 0 1 0 0 0 1 0 1 0 0 1 1 1 0 0. This one is 1 0 1. This one is 311 minus 6 by 8 r, like that. Like that. This is a waveform. This is the straight line like that. Like transfer characteristics of a 3-bit digital to analog converter. This is the transfer characteristic of a 3-bit DAC, digital to analog converter. With this, the analysis is